We are back. We continue with page 7, and we're moving on to 43 on 808. Use a Maclaurin series in table 1 to obtain the Maclaurin series for the given function. So we have f of x equals x cosine x squared over 2. Okay, so from table 1, we see that cosine has a Taylor series representation, sum from n equals 0 to infinity, from -1 to the nth power x to 2n and 2n factorial, with the radius of convergence all real numbers. So it will transfer to the new series that we are going to determine. So notice that if we replace x by x squared over 2 in the Taylor series, n equals 0 to infinity, -1 to the nth power, x squared over 2 raised to 2n, and over 2n factorial. And let's see how we simplify this a little bit. So notice that x to 2 to the second power raised to 2n will be x to the 4n. n equals 0 to infinity, -1 to the nth power, x to 4n. And then 2 to 2n, because it's in the denominator, will go to the denominator, 2 to 2n times 2n factorial. Okay, notice that we determined the Taylor series representation for this, but not for x times this. So now we're going to multiply both sides of this equation by x. So f of x, which is x cosine x squared over 2, it's the same thing with this, but power 4n plus 1. So -1 to the nth power, x to 4n plus 1 divided by 2 to 2n times 2n factorial. And the radius of convergence is the same because it's a new series from an old series. Okay, moving on to 61 on 809. In 61, we're asked to determine, to evaluate the indefinite integral as an infinite series. So we're given the integral from cosine x minus 1 over x dx. And they want us to evaluate this using, so find the sum of the series. Evaluate the indefinite integral as an infinite series. So we have to change the function into an infinite series and then find the integral. So let's build the function first. So first of all, like before, we had that a minute ago. So cosine x, we know, has this Taylor series representation, -1 to the nth power, x to 2n divided by 2n factorial. But now we want to determine cosine minus 1. So we're going to subtract 1 from both sides, and let's see what happens. Cosine x minus 1 will be the sum from n equals 0 to infinity, from -1 to the nth power, x to 2n over 2n factorial minus 1. So let's see how we incorporate this, or if there is any way we can simplify it. Yes, there is a way to simplify this, and here's how we do it. When n equals 0, this is 1, this is 1, this is 1. So n equals 0, this is 1, minus 1 would be 0. So we have to simply start at 1. And that takes care of the -1. So -1 to the nth power, x to 2n over 2n factorial. Now we have also x in the denominator. So we only have this piece. So now I'm going to divide both sides by x. So then cosine x minus 1 over x will be the sum from n equals 1 to infinity, -1 to the nth power, x to 2n divided by x will be x to 2n minus 1 over 2n factorial. So all this work was to determine the power series representation of this. Now we will integrate. So the integral from cosine x minus 1 over x dx will be the integral from all this of course dx, and we're going to get of course a constant plus, and let's see what we have left in here. So when we integrate, and all that happens is this is a constant, so we are integrating this, so it would be power x to 2n minus 1 plus 1 over 2n plus minus 1 plus 1, right? So the whole thing is just negative 1 to the nth power x to 2n, because it's 2n minus 1 plus 1 and over 2n. So 2n and times 2n factorial. I don't know why I wrote dx. Makes no sense. Makes no sense. I already put the constant in front, so it's done. For the same reason that cosine had the radius of convergence r, the new series from the old will have the same radius of convergence. Okay, this was 61. Let's move on to other types. And that's my page 9. Okay, let's look at 79. Still on 809. And we have the sum from n equals 0 to infinity, negative 1 to the nth power, x to 4n divided by n factorial. Here's the question now. Find the function represented by the given series, Taylor series. So let's see how we address that. That's 79. Okay, so if you carefully look at table 1, you will see that this is nothing else but the fact that this is an alternating makes the answer e to negative x to the 4th power. That's all we need to do. Just look through the table 1 and find what we are looking for, and that's what we did. Let's look at 83, same page, 809. In 83, they're asking us to find the sum of the series. So it is the sum from n equals 0 to infinity, from negative 1 to the nth power over n factorial. And if you again look through table 1, you will see that this is nothing else but Maclaurin series of e to the x when x equals negative 1. So then e to negative 1 will be just this. The sum from negative 1 to n factorial, and equals 0 to infinity. Okay, let's look at 85 on the same page, 809. In 85, they're giving us, it's the same question, but they're giving us a different series. So n equals 1 to infinity, from negative 1 to n minus 1, n times 3 to the n over n 5 to the n. Okay, so obviously, first of all, I'm going to rearrange this as 1 over n and 3 over 5 to the nth power. And if you look carefully, you will see, again in table 1, so this is table 1, and this is table 1. You will see that this is nothing else but the natural log of 1 plus 3/5, which is natural log of 8/5. So we found the sum. Okay, and let's look at one more, and that is 89 on page 810, in which we have 3 plus 9 over 2 factorial plus 27 over 3 factorial plus 81 over 4 factorial plus dot dot dot. So first of all, let's see how this looks like. So the sum. Now notice that this is 1 factorial, so 1, 2, 3, 4. I'll start at 1, and this is 3 to the first power, 3 to the second, 3 to the third, 3 to the fourth. So let's write it as 3 to the nth power and divided by n factorial. Okay, because when you look at table 1, this series, which is e to the x, in this case it's e to the third power, starts at 0. Well, we have to start it at 0. So n equals 0 to infinity, from 3 to the n over n factorial, minus, let's see what happens at 0. Well, it's only 1. So this series is the same with this series, but we have to start it at 0 in order to use table 1. So then the final answer is e to the third now. This is correct, e to the third, starting at 0, but minus 1. Thank you.